Okay, let me put this one on projects. Ghana. Where is it? Is it district? Did I close it? I hope I did not. File, open. Open. Okay, Ghana steady. Okay, open. Okay, so 0, admin 0, it's the national boundary. Admin 1 is the regional, and admin 2 is the district.
Oh, okay. That makes sense now.
Yeah.
So I picked this. This is the Accra region.
Yeah. Right.
So
Right.
this will
Right.
be the districts.
Right. Right.
Very good. So,
right.
Okay. So we are going to embark on geoprocessing and spatial analysis. And for this, you're going to see that we are going to be playing in between vector data and raster data. All right. And in here, you're going to see some of the workflows that we use in early warning systems. Yeah, and remote sensed data. So we're going to be building our capacity around this. So at this point, I want us to look some of the basic geoprocessing, because once we start working with raster data, we are making the assumption that you're already conversant with how to work with vector data. All right. Now, the first line of geoprocessing, right? I believe you're already conversant maybe with QGIS terminologies and processes. Some of this is going to be a repetition. Don't worry about it. Just
Okay.
Yeah. Now, I've been tasked. So whenever you are working with GIS, you decided to integrate GIS as a tool. We have it in different phases. We said that GIS cuts across the spectrum of your workflow.
Okay.
All right. We have already seen it at data capture, during primary data capture. So we also have secondary data. Okay. So most of this secondary data is usually at a very large scale, mostly at country level, regional level, especially if you're looking at things like forest and vegetation monitoring, and climate monitoring. If you're monitoring climate, if you're doing early warning systems, famine monitoring, you will be working with secondary data and raster and remote sensed data. Okay, so I'm going to start off by just saying we want to be able to monitor vegetation index of Accra, maybe for the last 5 years, right? So we usually, that's maybe a little bit. Okay, so anytime you're working with a GIS system, this should be your workflow, okay? Or your thought process. I want you to think of it as your analysis work plan, how you're going to execute it. It's a good way. You don't just work haphazardly. So the first thing that you have to understand, what do you want to accomplish using the GIS technology? So you state your problem. What do you want to accomplish? Right? For our case, we want to monitor, right? Vegetation cover or vegetation index for Accra region. for the last 5 years. So we're in 2025. So we should be able to get historical data spanning back 5 years ago, maybe up to 2020. Right? So the second step, once you understand your problem, you come to the next phase. Okay? Do you have the requisite data? So you get the data. So I'm looking at Accra region. I'm looking at vegetation. So I'll need map files for Accra. Okay? I'll need map files for Accra. So now where do I get map files for Accra? I download the administrative boundary map files for Ghana. All right. So let me do something here a little bit. There was a filter I've done here. This is a spatial filter. I'm just going to clear it. It's here. I'll clear so that you see the entire thing. Oh, still there. So where do you get your map files for Ghana? You can go, we said you can access it from HDX. You can access map files. We have very good resource for map files. You can go to Global Administrative Portal, that is GADM. All right. If you're within FAO still have a resource. I think it should be where. Okay, this is part of FAO, Farmer in Early Warning System. We have spatial here, and FuseNet. Let me maybe type it somewhere. Just a minute. So we have this resource, FuseNet. It's a resource that is from FAO, right? I'm not going to go into the nitty-gritty of FuseNet, but it just stands for Farmer in Early Warning Systems.
No signal, right?
Yes. And in here, we have agroclimatology data. Right? So if you look under the data section, you should be able to see the different data sets that are available. Okay, so we have interactive data visualization. We have acute food insecurity data, markets and trade data, agroclimatology data. This is GIS data. Livelihood zone, this is GIS data, and geographic boundaries. So you can access geographic boundaries to access your map files. Right? So if your organization or your project already has a resource like this, or maybe have recommended a resource like this, then be getting your map files from the resource. Yes. So in here, we can pick Ghana. Did we get it right? Yeah. Let's say Ghana is West Africa. So
Interestingly, it's not here. Wow. It's not here. It's not. That's interesting. But then
yes.
Looks interesting. I saw something. It looks like they are also picking it from humanitarian, the humanitarian side.
The HDX.
Yeah. It looks like they're also picking it from. If you go up, I saw something when you were scrolling through. No, just scroll down the main page. No, let's go. Yeah, I saw something like, yeah, humanitarian data exchange.
Yes, this one here, and GADM.
Right.
And FAO. Yes,
Right.
we also have this one here.
Bad gateway.
It's offline, It's offline. The server is offline. It's okay.
Right.
We can come back later, but there it is. So they're also picking it from here.
Yeah. Or we check GADM. We can also check database of global administrative.
Yes. So we had already downloaded the Ghana map files from HDX.
Okay.
All right.
All right.
I'll still
All
walk
right.
you through. I don't know, did I walk you through how to download
Yes.
from HDX, right?
Yeah.
Yes.
Yeah. Yeah. We're fine to go. Don't worry about
Okay.
that.
All right. So let me maybe close this for now. So I have my map file sitting somewhere under FAO. FAO. Now, this type of data sets, I believe at FAO, for FAO, your computers are already configured to work with SharePoint and OneDrive.
Yes.
You have a problem on how, or if you are wondering how you can set up that for your use case, you can let me know. We also have the Google Workplace. Google Workplace is the equivalent of SharePoint, but for Google. The Google Workspace, Google Workspace. So you can also have that form whereby your computer or your device is linked to your cloud resource, right? So data is saved both on your desktop and also updated on your cloud. So you have access to your data remotely at any given point in time. Whatever changes you make are also synchronized to your cloud. So
Which one would you say we go? We should do the SharePoint or we do the Google Workspace? Because some of them may be, which are there's like private studies. Do we want to, should we look at it?
okay. If it's for your organization and they are on Workspace, they will be on SharePoint.
SharePoint.
Yes. Now, what you usually need to do is to download the OneDrive for SharePoint. You download the OneDrive application. All right. The OneDrive desktop application allows you, I don't know whether, I think it's not on the other machine. Let me see. Yes, you download the OneDrive application. So this one allows you to install. As you're installing it, it will request to connect to your specific account. So for FAO, it should be able to connect to your user space, storage space.
We have one, yeah.
Yes. Now, how do you know this has been implemented? On this side here, you should be able to see you have OneDrive. So you can see this is OneDrive for my SharePoint, and this is OneDrive for the normal OneDrive account. So in here, I'm accessing under capacity outcomes. This is SharePoint. I can access the SharePoint. So it's here, right? And then I also have the option for OneDrive. So you should be able to see them here. If it's Google, let me see. Drive. Did I turn it off? Google Drive. Use Google Drive. So also Google Drive should be listed somewhere here. Will still behave the same. So you'll be able to have access to your cloud resource offline. All right. So you only need just to be saving to these drive locations that are linked to your cloud resource. That is the trick. Yeah.
Okay.
Yes. So okay, that is done. That's out of the way. Now that is the modern way of collaborating, right? Now, as much as this is very good because it offers a less technical way of managing your data and work files, proper geodatabase management requires you to have a proper geodatabase like Postgres. like Oracle. Okay. Especially if you're going to be running application, custom application. You've seen FAO they have a lot of applications that handle different data sets that are tailored for different use cases. Those who are monitoring climate, that is precipitation, those who are monitoring vegetation, all these things, those are in food security. They have these specific small apps that are running on the cloud and even on their resource. Like for example, this one here. Wait. Okay. So it has defaulted to, but if we access the home, okay, the different reports, the different tools should be under. Okay, under here. So if you're going to be building applications, like your land management system, like the Uber, there has to be a proper database.
Before we go,
Yes.
I will say, would you think, or no, what would you say could be the reason why, like a place like FuseNet hasn't got Ghana? Is it because we don't have enough data? Because that could be probably the reason, or the data they are picking is not accurate.
Okay.
Because I'm surprised that in such a place, I'm just looking at it, and Ghana is not. Especially between you and I feel that we talk a lot, but implementing things is really on the minimal side. There's a lot of talk shop in this country, to be honest with you.
I'll start it basically. Like Farmine, this is an early warning system. The spatial data infrastructure is not cheap. Okay, because you're working with satellite imagery. So it requires, apart from the funding, you also need to have a technical team, the human resource. And then you need to have policies and procedures. Basically, you need to have structures. Which organization do we currently have? FuseNet Ghana, right? So who is implementing FuseNet? Why are they maybe not considering having Ghana data sets inside FuseNet? So if you look at what FuseNet has done, it's mostly using EU data. European Union data. So they also have their own space program or Earth observation program, just like NASA. It's called ESA. Right? So yeah, these are some of the things. But not to worry. What FuseNet has done is that they have just taken the satellite data that we have not been making use of, and then they are building out products from the data. They are building out, apart from the reports, apart from the maps, they are building also apps. Okay? So, and this has a lot to do, there's a lot of funding that goes in. It's not free. Yes. So if you ask me, is a challenge of funding and also the buy-in.
Mm-hmm.
And also we
I got
have
it.
geopolitics involved.
Mm-hmm.
Yes.
Mm-hmm.
Like for
Mm-hmm.
Kenya, we also have our own Earth observation satellite that is only basically for East Africa, but mainly it produces data products for Kenya, agroclimatology data for Kenya.
Mm-hmm.
Yes.
Mm-hmm.
So you can see if your government now opts to, if they believe that spatial data is going to help them, then such commitment and contribution from the government and the available systems is one of the things that you know will determine whether we have a robust infrastructure or not. So, but we'll get there. We'll get there. FuseNet has come a long way. Initially, when they started off, we didn't have enough data. But right now, when you go through, you should be able to find most of the areas are catered for.
Mm-hmm.
Yes, maybe not. Maybe in terms of temporally. Temporally basically refers to time scale.
Mm-hmm. Mm-hmm.
For some regions, we might have gaps in data, maybe spanning maybe into 1990s, 80s. We might not be having that data for those regions. But
Mm-hmm.
as far as the millennium is concerned, from 2000, we have enough data for the last 20 years for most regions, yes.
Okay.
Yeah, so policies, I'll just say policies and commitment.
Okay.
Yeah.
All right.
But now, FuseNet is not the only place you'll get this type of data. Also, NASA, if you know how to work with your agroclimatology data set that we get from satellite imageries, you should be able to produce the same products that FuseNet is producing.
Mm.
So the beauty about FuseNet, we are getting already pre-processed data.
Mm-hmm.
All right. So pre-processing of satellite imageries or remote sense data is usually an expensive and a highly technical affair.
Mm-hmm.
Yeah, that is not everybody can do it,
Mm-hmm.
but we can use the data products.
Mm-hmm.
All right. The data products have been developed and toned down to what the normal person can understand.
Mm-hmm.
Yes.
Mm-hmm.
Yeah, that is usually the challenge with remotely sensed data because we're using sensors.
Mm-hmm.
Yes, and what the data that we get is usually sensor reading. So we have to pre-process it and then use it. That is why when you're working with the remote sensed data as a GIS professional or expert, we recommend that you understand a little bit history or metadata around your data set.
Mm-hmm.
All right.
Mm-hmm.
Is it pre-processed data? Is it raw
Mm-hmm.
data? Okay. A time frame. When is this data from?
Mm-hmm.
Yes, those are some of the things that we look at, spatially and temporally, or spatial temporal considerations.
Mm-hmm.
Yes, we will get there. We have a lot of players that are in here. Now, FuseNet is not the only one. I'm going to share others. Like for climate data, you can look at World Climate. What is World Climate? Yes, World Climate. So like this is World Climate. We call it World Climate. So it's a resource for global precipitation data or climate data. So you can get historical climate data, historical monthly weather data, and future climate data. Okay, so in here you have temperature, minimum, maximum, average, precipitation, solar radiation, wind speed, and water vapor pressure. Okay, you also have bioclimatic variables and elevation. Okay, yes, elevation. So yeah, and then for soils, I'll still opt for the FAO soils portal. Okay, yeah, it's best. This is one of the best qualities of data sets that we have for soils. Um, For NDVI, NDVI also, or FuseNet has a very rich resource for NDVI datasets being collected by every satellite mission. We also have eModis. eModis is an earlier version. Yeah, so it's here. Okay, so you're going to notice that most of these resources, in some way, they are collaborating and sharing data in between themselves. Yes, yes. That's what we say with GIS data. If that data is already available, you don't need to create yours from scratch. Yes. And the beauty with the cloud technology now, remotely sensed data like vegetation and precipitation can can be hosted on the cloud, and you have access to it at any time you want, real time. All right. So SRTM is a resource for elevation data. SRTM simply just means the shuttle radar terrain mapping mission. It's basically just to look at the elevation of the globe. So it's an elevation data set. If you're looking for altitude, all right, yeah, it's very good for modeling, especially if you are modeling, doing geospatial modeling. Yeah, it comes out very well.
Okay.
This is still FuseNet. Yes. So where do we were here? Now, once we get our data sets like this, we don't work with everything. Okay. Like for our case, we are going to maybe focus on Accra, right? I know it's dominantly urban area, but I think we have some vegetation. We can monitor that vegetation, and we're going to do it real time here. All right. So get your files. Remember our process. So you get your data. So you need to understand where am I going to get the data, and then you need to understand how to process data. So if you're going to work with vegetation data, if you're going to work with climate data, you need to understand how we handle climate data. You know how to handle weather data, like maybe temperature, rainfall, NDVI, things like those. How is it handled? How is the data processed? Right? And then how do we now merge the data and use it for research? All right. So if I have this data, if I have spatial data, how do I maybe draft my theory of change? Right? How do I build my theory of change using geospatial data? So this is usually a challenge for most people, defining theory of change using geospatial techniques. So if you're going to be using GIS, it's also going to affect your theory of change of how you're going to also draft it, because you're going a notch higher. Then once the data problem is solved, you now start working on the problem to solve it. That is the part you analyze. So analysis here has a lot to do with managing your data, cleaning your data, making sure it's of very good quality, and also in the format that is usable for your use case. Right? And also it means, running the different algorithms, the geo algorithms that actually now, you can call them formulas. The algorithm are formulas. We are used to formulas in Excel, formulas in Power BI, but now this time you should understand what formulas and functions, spatial formulas and functions are there to help us process our geospatial data. All right. And then presentation of findings. Right? So if you're working with remote sensed data, satellite imageries, how do we present the results? Right? If I was doing change detection, how would I present findings for change detection? will I maybe talk about the rain, or maybe I'll talk about the rate of change? Because if I'm looking at the entire district, then for me to measure maybe annual and minimum rain might not be feasible. So I can look at the change detection. So in most cases, one of the main areas you will work with remote sensed data is in change detection.
Mm-hmm.
And this is still under monitoring. Change detection is monitoring. Right?
Mm-hmm.
So you want to see that we have long-term averages, long-term means, anomaly maps. Anomaly maps are maps that just shows the rate of change between an earlier year, an earlier date, and a current date. It can be the change maybe from 2020 to 2025. If you find the difference and that you plot that difference on a map, we call it anomaly map. Right?
Okay.
So let's get to it. Let's get to the nitty-gritties and do it practically so that all this makes sense. So this is going to be our workflow. We state the problem, we get the data, analyze the problem, present the finding. Most of the time under here, that's where your case study is. This is where you define your case study.
Okay.
So we are going to do, we're going to monitor. I have rainfall data sets. I have temperature. I have soil data set. I have NDVI data set. So we want to see how to work with this. So the first thing that you need to do is to start with your map files. Maybe let me close this for now. So we are interested with Accra. So we are going to reduce this data to our region of interest, right? Or what people call ROI. I know for accountants, ROI is a different thing, return on investment. In GIS, ROI is region of interest. So you need to understand the data from where you are downloading your data. You need to understand how the data is structured. So like for a case, we've said admin 0 is a national boundary. Admin 1, that is what? That should be the region.
Yes. Admin 1 is regional.
Yes. So we have Greater Accra and we have, I think Accra is here, Greater Accra. That is a region. And then you have districts. So I'm going to pick the Greater Accra region here. I only minute. Okay. So I'm going to concentrate on this region here. All right, so how do we reduce this to our areas of interest? Now, for example, these are the different regions that are within Accra. So we have the select tool in here. And this is also present in most, it's one of the traditional functionalities of any GIS. You should be able to select features. Okay. You can see QGIS uses the yellow to just show which feature is currently actively selected. Okay. Now, that is one of the ways you select. So how do you do it? Like for example, I can say Greater Accra. If I wanted only this area, I'll come and say, just select it the way it is. And then, now you see your data sets here, you can rename them here. So I'll say this should be the region. I'll rename this.
Oh my God. Then please excuse me, please.
Okay.
Yeah, I'm back, please.
You're back.
Yes.
Wait.
Mhm.
So so you said the first option is to select and then extract it. How do I extract this selected feature here? Maybe let me zoom it so that we have a very good. Greater Accra. So that is under region. So to just get only the map file for Greater Accra region, right click on its map file. All right. Each of these map files that you are seeing displayed here, you can see we have a base map, we have the greater region, regional map file, and then we also have district file. They're all displaying in here simultaneously. This skill of displaying different data sets simultaneously on one screen is what we call overlays. Okay. If you also had roads, we put it here, rivers, we put it here, pipelines, we put it here, power lines, we put it here. Anything you want to work with that is relevant to your what you are doing.
Let me. Okay, that's okay. That's fine. I was going to say that I was going to download the region, but it's okay. Let's go ahead.
Okay. Okay. Maybe let me just show you what we are working with so that you're able to get it on.
Let me see.
On the
Check.
online resource.
I want to check the attribute table. Yeah, that's fine. Go ahead. That's okay. I think what I have would work.
Okay. All right. Now,
So let's go ahead.
yeah, you've mentioned the attribute table. Attribute table is also one of the ways you can get hold of what you want, of the map file that you want to work with, because we said for every map file, there is a record behind it, a data table. Right? So you can use a normal data querying to also filter to what you want. So this is the first one, Ghana regions. I'll come here and say export. All right. And then I have 4 options in here. What I'm looking for is save selected feature as. So the feature in GIS, the feature is a drawing. It can be a polygon, it can be a point, it can be a line.
But if I may ask, I noticed that when I did the regional,
yes,
and I went to the export, the save selected feature is not highlighted. Is it because I have not selected it? Let
yes,
me.
it's because you have not selected. Once you select, just use the select tool.
Let
This
me
one.
just. I think I've selected the wrong thing. Let me deselect.
Okay, you can screen share so that we look at what.
Deselect. Ah, okay. Go ahead. I
Oh,
got it now.
all right.
Yes.
Okay.
Sometimes I like to be challenged on these. Let's go ahead. Yeah.
That's GIS for you, don't worry.
It's interesting. Yeah, that's good. So export,
So,
save selected feature. Why?
save selected feature as.
But here,
Mm,
I think one before
mm,
we go to the selected feature,
mm.
do we write a script before you save?
No, you
Do
don't
you?
write any script. At this point,
Mhm. You just click.
we are just using the manual, the
The manual.
visual.
Okay. Let me see what is this.
Yeah, this is just
And
visual.
could you
At
could
some
you
point, you're going to be
minim
writing functions and
could
syntax
you minimize? Yes, minimize this. Let me see something. Minimize
and
the
minimize it.
window. The select. No,
Oh, okay, this
just
one.
close the select window because it looks like what I'm getting is not okay. First of all, let me put in a label because I'm not getting the same thing as you have. So let me go to symbology and put a label. What's happening? Symbology label. Right. Mm.
I'm using the
Nothing.
admin
Nothing shows
one.
under symbol.
Yeah,
My
admin
labels.
one English.
Nothing shows under my labels. Okay, so first of all, because the
Let
ridge,
me
the
repeat.
greater.
Let me repeat that how to do the labeling.
Okay,
Yeah.
okay.
Now, for ArcGIS, it might be a little bit different, but in QGIS, it's quite straightforward.
Yes,
We
I'm
have
using
this
QGIS.
window that calls
I'm
layer
using.
properties,
Mhm,
and it works together with your data table.
mhm,
So you can configure symbology. This has to do with the colors, the field,
mhm, mhm.
and then we have labels. This has to do with the labeling. So under
My,
this
my,
labeling, we have three modes you can use to label. We have single labels, rule-based, and blocking. So the
wait
most
a sec.
common ones are these two,
Wait,
single
wait,
and
wait, wait,
rule.
wait, wait, wait a sec. Wait a sec. Wait a sec. I think I have to close this and save it back. Let me save this because when I go to the labels, I don't see anything. So let me close this. Close and then open it again. QGIS. Oh
Make
my.
sure your vector data set is one currently highlighted. The one currently
Okay.
active, yes.
Right. QGIS. Let me put it on. Okay. All right. So what do we do? Let's go here. And then Ghana. Okay. Let me go to regional. Um, hmm, hmm. Where's that? Go. Come on. Symbology. Okay. Labels. I'm not getting my labels. It's not showing.
Okay. Just
But
screen share.
don't worry.
Just screen
I
share.
was
Let
saying
me
that.
help you out.
Okay, okay.
Yeah.
Share.
Yeah, you can share now.
Okay. Screenshot.
Mm-hmm.
Yeah. Okay. All right. You see my screen here.
Mm,
So the point is this. So we have this here. I've selected the
mm,
regional boundary as we
mm,
see here.
mm.
But when I go to
Scroll
the
up.
labels, you
Scroll
see,
up.
you go there. Okay.
You see on that bar, on that panel, just
Mm-hmm.
slightly on the edge, there should be a navigation bar, up and down, a vertical navigation bar. Yes, just scroll it up. You should be able, yeah, you can see there we have other options. So what you're looking for is the labels.
This is here.
Yes. Now, currently you can see there's a drop down. Just click on that drop down. Right? Now you access the other three. You pick single labels. And then you define which field within your table to be used for naming or labeling. Yeah.
Okay. So, okay, I got it.
Mm-hmm.
I got it. All right. So
You can
I think we just
specify the
let's just go.
fonts.
Let's go with this.
Okay.
And then I apply.
Mm.
Okay. I say okay. Got it. Later on, decorations can come. This is fine.
Yes. 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 Right. We proceed.
And then, yeah. And
So you
then
use the
you
select
said,
tool.
yeah. Okay. So the select tool is here, and then you said greater Accra region.
Yes.
Okay.
And now try the export. Try
Right.
exporting it.
Then now it's going to work.
Yeah.
So we go here, export, select, save selected feature as. Okay. I have one sec here.
Okay.
Package, greater
Now,
Accra.
be keen on the formats. On the file formats is currently defaulting to GeoPackage. GeoPackage is a default file format for QGIS. So depending with where you want to have this, you can have it as a GeoPackage, S3 shapefile, or you can still pull it into Postgres.
Okay.
Yes.
Okay.
Yes. So let's start with the first one. Now, if you are going to be doing geoprocessing inside QGIS, then you are better off working with GeoPackage and S3 shapefiles. I know your data might come in various formats, but to really have a good field time with this, make sure your data sets have been converted either to S3 shapefile or GeoPackage. So because I'm reducing this data to Accra region, we can use, I want us maybe to use S3 shapefile. Let us use S3 shapefile for now. Okay. And then you provide the name. This S3 shapefile has to be stored somewhere. So you have to provide the file path by, there's an ellipse button in front of that file name text box. Okay. Now, have it under a common folder for this exercise. Yeah, just find somewhere to store it. Yeah, you can go, yes, save. I want you to look at the coordinate system. It's WGS84. This one is for mapping. Okay. Yes. Just maintain everything the way it is and just say okay. Now we have our Greater Accra region down here. Yes. All right, let's try and get maybe districts within Greater Accra region. How will we do that?
Districts within Greater Accra. So that I would go
wonderful. Yes.
Here.
Yes.
And then
check it, activate, yes.
Activate. And let me deactivate this for now. Then
yes. Now, if you're not familiar with the data set, always make use of the open attribute table, right? It will help you see the data table. So within the data table, you should be able to see the different column headers.
Okay, I got that. And then we can select only Accra.
Yes, that should be coming under ADM1, right?
Yes,
So we're
ADM1.
going to use ADM1 to filter. We're going to write a filter syntax to only filter or to only return districts within Greater Accra, right? So for this, we will, how do we write your filter? You go back to your layers panel and right click on your district dataset. Just close.
Okay.
Okay. Right click. So what you're looking for is a filter option. Filter, 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 up. There. Yes. Yes. So when we're talking about queries, spatial queries, this is one of them. So we're going to use this spatial query to filter down or to reduce district dataset to only Accra districts. So I'm going to pick ADM2. Sorry, I'm going to pick ADM1 EN. So you can see we have it's divided into three parts or four parts. The fields panel, the values panel, the operators area, and the expression area. So we are going to build our expression visually. So this is what we call visual programming or visual statistics or visual analysis. This is what it is. Double click on ADM1 EN, ADM1, double click. Just double click. Yes, notice what happens under your expression box. Yes, it starts building your syntax. So for the operator, you're going to say, you can use equals, you can use like. So I'll just say maybe equals, and then under the values, okay, the values box. Currently it's empty, just select all. Okay, so these are the, yes, you double click on that also, Greater Accra. Yes, this is how you build your filter syntax. Okay, so before we run it, we want to test if the syntax is it's working. Down there at the base, you have buttons. The second button is test. Okay, it should hit some return. Tells you have 29 rows.
29.
Yes, so that means you have 29 districts within Greater Accra. Okay, so now at this point, you can just say, okay. All right, there. Now, I want you to notice, so these are your districts. So you have to also export this. Yeah. But this just save feature, the normal one, save feature as. Yes.
Okay.
Yes. And you can have it as districts in Accra, Greater Accra districts. Find a way of, can have an underscore for districts, yeah. Then point it, yes. You're doing well. Good. Now, our data sets is ready, but we are only remaining with one more data set. we need to get the NDVI dataset. Okay, so where do we get the NDVI dataset? We go to FuseNet. Or maybe we can start maybe with precipitation. Let's start with precipitation. I want you to navigate to worldclimate.org.
Worldclimate.org.
World climate, yeah. World climate, or what that is.
Okay.
On your browser, yeah.
Yeah. Let me get a new browser.
Yeah, the first one. Download. Great. Just scroll down a little bit. Yes. Select historical climate data. Yes. Scroll down. Good. There you are. So for now, I'm going to explain what this means. Once you start working with the raster datasets, we have what we call a resolution. We said that rasters, they use pixels to store data. Right? So the images are comprised of small boxes, just like the way you zoom in your image. The smallest element of a picture is called a pixel. So the number of pixels you have per area determines the clarity or the resolution. Okay, so the higher the resolution, it means it is more refined. It's very clear. Okay. So you can see we have 10 minutes, 5 minutes, 30 seconds, and all that. So we're going to pick, maybe for now, I want us to pick precipitation. Pick 2.5, maybe pick 2.5 for precipitation. 2.5 meters. The third last column under precipitation. Yes.
Yeah.
Yes.
Oh, okay.
Yes.
So
the higher the resolution, also the higher the download size of your spatial data set. So if you try maybe like the 30 seconds, you'll see it will tell you something like 4 GB. So maybe let's pick for, you can download that. The higher the precision, even the better the analysis. Okay, so if we have the time, you pick the 30 seconds. Right, but for now, just pick the 2.5. Yeah,
okay.
I'll show you how to work with it.
Let's go to.
You can give it a folder, precipitation. Yeah, just like that. The S should be a C.
Okay. Okay.
All right. As it. I'll navigate to. Let me just share this. Let me share it to the chat.
Sure.
The resource for FuseNet, where we are going to download NDVI dataset. Coming on your chart. Yeah, this one is for West Africa. It's coming from the EVIRS. This is one of the most recent satellite missions for NDVI data collection, right? Vegetation monitoring. So you can see, at least at this point, you get data for Ghana. So we have temporally smoothed, we have mean anomaly, and we have previous year difference. Okay. We want to pick two, the temporally anomaly and the mean anomaly. Okay, so start with the temporally smoothed NDVI. So click on data. Yeah. You can see it's a zipped file.
Okay.
Yes. You can also do now. Before you start picking it, there's a box just next to on the right that says pentadal period. It says the year and the pentad. On your right, just there, on your right. Yes. So it allows you to work with historical data. Just click under the year drop down. So you can pick your data way back to 2012. Okay. So you can look at what were the NDVI values at 2012, 2013, 2014, 2015. So if you are, this is good data for change detection. Okay. So we've picked for 2025. I want you to pick for 2020. Maybe we look at 5 years.
2020. Yeah.
Yes. Now there's something under pentad, the pentad option. Pent means 5. Okay. So this is data within a series of 5 days, within a period, a revisit period of 5 days. Every 5 days it picks. Every 5 days it picks. So resulting for the whole year, how many? 72. You can change this to monthly. Just select drop down.
Okay.
Oh, it's not there. Click outside. Just click outside. Let me see. Oh yes, yes, yes. Okay, we did the 47. The one we downloaded was a 47 pentad. I wish we work with monthly data, but it's okay. Just pick pentad 47 so that it matches with our data set for 2025. There. So these are all corresponding to the same place on the temporal scale, right? So if it was January, we pick 2020 January NDVI, and then we pick also 2025 January. So if you are looking at months, you compare months within months. This is agroclimatic data. So it's affected by seasons. Okay, you cannot compare January and April. or maybe January and September,
Mm-hmm.
right? In one, it might be a harvesting season. In another, it's a planting season. So vegetation will actually be affected through human or anthropogenic factors. So we say you compare January data sets to January data sets. So January with January. So if you're doing your analysis, you look at the data sets for January and you get the difference between the years. If it's February, all your data sets should be February for the different years. All right. I'll circle back to this. Don't worry. I'll explain why we usually do it like that. So now the reason why we are saying if it's 47, 2020 47, then 2025 also 47, the 47th pentad. This will remove errors. Imagine trying to measure vegetation within a month that had enough rainfall with another month that didn't have rainfall. It will give you wrong results. Okay? Yes. So that's why we have to match them like that. So do that. Have you downloaded for 2020 down there?
No, I was waiting for you to
Yes. Now
finish
go
this.
again.
So
Go
I
again
can
and click
go.
on data. Yes. It will now pick for 2020. All right. So you can see 2020,
Yeah. 24.
2047. Yeah.
Yeah. 25, 47, the same.
Yes. So the WA means West Africa.
Africa.
Yes.
Okay.
The 20 means the year.
Yeah. Right.
The 25
Is the PA.
yes. The
Is the
47 is the
peak.
pentad period, or the pentad number. That is temporal, eh? Yes. So we keep it like that.
Okay. Okay. Are we using only two, or we go further?
Yes. We'll pick for now. We'll pick only these two. If you want to have deeper, in-depth analysis, you can pick for the entire year.
Okay.
But I want to warn you, it's going to be bulky.
All right.
Okay. But you can download at your own time. Just make sure you get all the data sets. Okay. So for now, I need you to extract these data sets.
Okay.
Once you move them, yes. And then you're going to release the screen share so that I walk you through the first thing of geoprocessing. Yeah.
Yeah. Sure. Okay, give me a few minutes. This one we will call it
NDVI.
NDVI.
Mm.
Good. Precipitation area NDVI. Okay. Then we go. Let me release it so you start preparing. By the time you finish out that.
Okay.
Okay. So show more options. Extract all. Extract. Okay. And then here also extract all. Extract. Okay. Great. Yeah, it's done. Okay.
I missed a step. Should be export save selected features. I think I should use the same link I sent. Just give me a minute. Okay, there. So from within my QGIS browser window, I have the NDVI datasets here. So I'm going to load the earlier one, this one, by simply drag and drop like that. And then also load
Okay.
the second one.
Let me load.
Okay.
Where do I have this one? Users, documents, OneDrive, GIS study, and
There's trouble here.
Mm.
I need you to
Mm.
look at
1 sec. Let me just put this,
okay.
and then I will join. I will look at it. I want to see GIS study.
The forest is disappearing in Accra. The vegetation cover, I think there's a lot of build up
Say it
going
again.
on. Yeah.
Say it again. Say it again. You have said it. You've said it right. You see, that's how I was telling you something yesterday that
Mm.
a lot can be done. So you've
Yes.
said it right. We're joking. Okay, let's go ahead.
Okay. Mhm. So this one was in 2020. This is 2025, same period.
My brother, this is serious.
Where did the vegetation go to, especially this area?
What?
It disappeared.
Wow.
So this can also tell you where the urbanization trends, where it's spreading to. Okay. And agricultural lands if they are there. Anyway, so your raster data sets. We were able to load our raster data sets, and this is a NDVI, temporally smoothed NDVI for 2020 for Western Africa. Now, this is very good, but we don't need everything. If you expand a little bit on this raster data set here, I want you to notice the icons, the ones that have a box that looks like checked, these pixels, that refers to raster data sets. So below these values that you see green, they actually is a representative of NDVI values, and you can look at it. It runs from 0 to 256, I believe. Yeah. So this one here is good, right? We can use it. So wherever you see a lot of green, that means there's more vegetation cover. Okay, yeah. And then as the quality goes out, fades out, and transitions to like the light brown and all that, that's where we are having low vegetation cover or few vegetation cover. So let me say sparse, dense vegetation cover and sparse vegetation cover. Yes. So just like weather data, that is temperature and rainfall precipitation, NDVI also is used for farming early warning systems, right? It's also used for change detection, right? When the weather or the climate is affected, let's say maybe there is more rainfall, then that particular region will tend to have dense vegetation cover because of the good quality of water and nutrients and all that. And then when it goes down, when the temperature goes down, rainfall also goes down. There's a direct effect on NDVI. So if NDVI is going down, rest assured that also precipitation will be going down. Okay, the quality of vegetation will be going down. If it's improving, and if also the exposure, the number, the months where we are having adequate rainfall, if that period is also improving, you'll also see that during those periods, you'll see a spike in NDVI values, meaning an improvement in vegetation cover and quality. Okay, so let's process this data and put it to use. Okay, so the first thing is to reduce this data to our area of interest. So we are now working with raster data and vector data simultaneously. So how do we process this? So if I'm looking to have data for Ghana, just the Ghana country level, then we use geo algorithm. We have geo algorithm. Most people know it as geoprocessing. So the first one that we're going to do is to run a clip. A clip is a spatial filter that allows us to reduce our raster datasets. Now I want you to see our raster datasets. They don't have any table behind it. But the pixels are the ones that have values. If I load this into Saga JS, you should be able to see it properly, the values, but I'll just keep it the way it is. But you can use the identify tool, this one here, and just click anywhere, and you should be able to see the values. Like here where we have just clicked on this red dot, it has an NDVI value of 181. If I pick around this Accra region, you can see it's 125. If I pick maybe here, this is 109. I'll try somewhere on the green here again. This is 177. So you can see that behind this raster data set, behind the pixels is a representation of the values. So data within raster is stored at pixel, not in a table, it's stored in the pixel. Yes, that is the difference between a normal vector data and a raster vector. And a raster data set. So yeah, that's it. Now, how do we reduce down this? We want to use a clip algorithm. Okay, this one will help us, is a spatial filter. So how do we run it? First of all, we need a vector data set for the area of interest. I'm going just to say our study area. So I'm looking at Greater Accra region. Okay, Greater Accra, is it? Bring it on top here. Can you hear me?
Yes, I do.
All right, go ahead. Okay, we were discussing this. Great. So to clip, so in this demo, we are going to see how to clip raster data sets in an attempt to reduce our spatial data set to our area of interest. All right. So requirements, we are going to require the raster data set. In our case, is a remotely sensed data for NDVI from EVIRS. And then we are going to require the Greater Accra region shapefile or boundary map file. Yes. So we are going to use the shapefile. Let me just maybe use the vector for Greater Accra region to clip our NDVI data sets so that we only end up with NDVI raster for Accra, Greater Accra region. Right now, NDVI files are bulky, and in GIS we say work with what you require, leave out the rest. If you're not interested with this region, leave it out. Focus on your study area. That's why we are clipping. So within QGIS, we have the vector menu here, and then we have the raster menu. So to clip your raster, you go to the raster menu. Clip, another name for clip is to cut. Okay? Or to crop. So clipping and cropping are one and the same. So we're going to crop this raster. It's an imagery to only remain with the one for Greater Accra. So we go to raster and you look for the extraction option. Okay, although we have others, we're going to see what they are doing. Even for the topography, raster calculator. Yes, we'll also work with raster calculator at some point. But now we're starting off with extraction. So we have two options, clip raster by extend and clip raster by mask layer. Extend, this is our map window, okay? So on this map window, the bounds of what is currently visible is what we call extend. And extend can change based on how you have zoomed, okay? You, if it's like this, then this will be the new extend. Let's say if it's somewhere concentrated, maybe here, that will be your new extend. And then we have mask layer. Mask layer just refers to your vector file. And in this case, the Greater Accra shape file. Let me give it an opacity of that is okay. Right, so that's Greater Accra region. Now we are going to run this algorithm extraction. So I'm going to go with the mask layer. Now, whenever you are clipping the two data sets, the vector and the raster, they need to share a similar coordinate system. That's a requirement. That's one of the procedures. We talked about procedures, the later. So our input layer is going to be our raster data set. And I'm going to pick, was it WA247, this one here? East Africa, year 2020, pentadal 47. You can see the coordinate system is 4326. And then our mask layer, I'll pick Greater Accra region, right, map file, which is still 4326. And you can see on the map, they are overlaying on the same area. That is one of the functionalities of a coordinate system. Yes. So as you're doing your spatial and your processing, your values are very accurate. Yes. So maintain everything the way it is. For now, don't change anything. Only one thing to update. Match the extent of the clipped raster to the extent of the mask layer. It's checked by default. And then the output. So every time you clip, you will end up with an output file. An output file is going to be generated. Every time you are doing a geoprocessing activity, the end product, the output is usually a file, a data file. So our clipped mask, our clipped layer, I want it to be stored somewhere. I'm going to say save to file. And I'm going to say Greater Accra 2047. I'm going to Greater Accra 2047. You can see I'm still tracking the year and the pentad. And then we save. yeah, replace like that. Now, once it's done, you can click on run. Okay, don't worry about that. It's done. Huh? So it's because mine had another one. So for yours, it should run smoothly. Now, you can see our Greater Accra. It's there, right? 2047. Now, NDVI is the way you handle rainfall data is the way you handle NDVI data. So the way you say you can have daily rainfall, you can also have daily temperature, and then you can have mean daily, mean weekly, mean monthly, annual. Is the same way with the NDVI. So you process it and you handle it like climate data or weather data for NDVI. So for NDVI, we also have monthly NDVI for January, February, March, April, May, June, all the way to December. Okay. And then we have long-term means and long-term averages. Long-term means is you take 30 years and you find for the 30 years what has been the average. Okay. That is LTA. LTM, which stands for long-term means, you are specific with the time. You can say long-term means for all Januaries. So you can have long-term means for all Januaries, where you're only using the values from all the Januaries for the 30 years, or maybe the 20 years or the 10 years. And comparing the Januaries, how NDVI has been varying for all the Januaries. If you are picking January, that is. If it's February, the same thing. So you're looking at all the averages for February, for the month of February. Okay. So for our case here, we are focusing on the pentad 47. Okay. Now feel free, you can still get NDVI for monthly. Okay, it's there. Let me show you. Here. Maybe let me circle back a little bit. Let me get you this. Your chat. Let me send it on WhatsApp. Which is better? WhatsApp?
Anyhow, you put both, I will get it.
Okay. All right. So in here, this is for West Africa, Pentadal, EVIRS, and NDVI. And then you can see we have temporally smoothed NDVI. So you can click on this and then pick downloads. If you pick graphics, it will give you the already processed maps. So click on downloads and then you can see pentadal and monthly. So you can go to monthly if you are looking to work with maybe January, February. You can see now this time. Yeah, you have, so the numbers. So this is 2012 from February, March, April, all the way to December. And then 2013. Is that clear?
Yeah, very.
Yes. So That is so if this is temporary smooth. So if I wanted maybe to find the annual, then I will add, let's say maybe for 2013, we add January all the way to December, and then we get the average. We divide by 12. All right. Yes. So just hold that thought. Now, let's just process this, and then once you're going to work on your case study. Back to QGIS. So we now have our data set, our raster data set, but it only it's only corresponding to 1 year, right? So this one I can map it, but it's not giving much information. So when you're working with agroclimatological data, you want to work with anomaly maps. When you're working with rainfall data, you work with anomaly maps. Anomaly, basically, they are describing the change, the rate of change. So anomaly is either the change can be positive or negative. So within our data set, I took the liberty to acquire for 3 more years. Let me just get it from here. So I have one here from 2012, and then another one here from 2015, from 2020 here, and from 2025. So 1, 2, 3, 4. So when you talk of temporal resolution, we are talking about time, the time scale. Okay. Yes. So I'll move this. I'll maybe have this copied somewhere for Ghana. Not there. Ghana. Did we really create one for Ghana? Oh, yes, it should be under NDVI. Yes, under NDVI. So it's here, I think. What to do with this? Let me just say, I'll create a new folder. Just call it Ghana NDVI. I'll paste it here. Once I paste it here, I'm going to do something. I'm going to extract all of them here. Can you see that? Yes. I can get rid of this. So we have from 2012, 2015, 2020, and 2025. So when you're working with climate data and vegetation data, you want to work with a period of 10 years, 10 years, 20 years, 30 years, 50 years. So averagely 30-year period. If you want to break it down, 10 years, at least 5 years, all right? If you compare maybe January and now, it might not give much change, but yeah, that's how we do it. But feel free to even reduce the change even to 2 years or 3 years, or even 1 year. So it's up to you to decide. But as during your analysis, you need to mention your temporal resolution or your temporal scale. Is it a 2-year period? Is it a 3-year period, 5-year period, 10-year period? If it's a scholarly work, then we are looking at not less than 10 years. Okay? Yes. Yeah, that's for your postgraduate and all that. Not less than 10 years. So the resource is there. Now, I've shown you how to clip only one file. Now, let's say you are working with even 30-year worth of data. Each year has 12 months, right? So if you are, let's say, if it's a period of 10 years, then you are working with 120 raster files for NDVI. Okay? If it's 20 years, if 30 years, even the number increases. So how do you process this? Now, within QGIS, you can process one file at a go, and then you can run what we call batch geoprocessing. In data science, we call this machine learning. Okay? So we are going to use this Accra map file to clip the files from 2012, the file from 2015, the file from 2012, 2015, 2020, and 2025. So we want to run a batch process. So how do we do that? For that, we still come here under raster. You pick your extraction and you pick mask by layer. Now, what we are running, this part here that we are running, you can find it here under the processing toolbox. You can see here you have the processing menu. And then below it, you have toolbox and model designer. Okay? Model designer is usually very good if you are doing automation. GeoScripts, if you're running GeoScripts. I'm going to show you, don't worry. Toolbox, so under toolbox is similar to ArcGIS toolbox.
One sec, please. One sec, please. Please. Come on. Yeah, go ahead, please.
Okay. Yes. The processing toolbox, we've said, you find it under the processing menu. Okay. Now, if you're not seeing the processing menu, then it means something here under your plugins. I'll circle back to plugins.
No, I have it.
You have it, eh? Okay. If by any reason maybe you're not seeing some of this, you come here under view. And then you find panels. Okay. So under here we have a number of panels. So make sure the processing toolbox is turned on. Yes. You can see we even have GPS information. Search QMS, statistics. Yeah, just feel free to explore these. This is where you find them and activate them.
Okay.
Yeah. Under view, under panels.
Mhm.
Yes. Now, each of these is just a collection of the different algorithms, geo algorithms that you can execute within QGIS. Now, I want you to know that QGIS is standardized. We have what we call GDAL. All right, GDAL is a set of tools, standards, tools. I mean the algorithms, and it's global. Right? So, and it's supported by all GIS. So, if GIS platforms or GIS softwares, they are standardized. You don't just run your own things. It's standardized. If it's clipping according to the GDAL standards. So we have also OGR. I'll talk about this later. It's like what you people refer to as standards in data protection, like GDPR, HIPAA, you know. Yeah. So this file here, if you clip it in ArcGIS, in QGIS, if you take it to a different mapping platform, it should be able to overlay where it was originally created on. Right? Yes. So it's very standardized. So you don't need to worry about the quality of what you are producing. Now, we have file tools. We have GPS. I was looking. We have interpolation, heat map, IDW, TIN. I think raster is somewhere here. Okay, so let's look at this historical data. All right, we're going to create a dashboard using remote sensed images. This was in 2012. This was in 2015. Okay.
That's 12.
Pardon?
That's 2012, 2015.
So in 2015, it seems like there was an increase, but we have no way of knowing until we start analyzing these files. But the distribution can tell you that it was an improvement. Because you can see these sections here, in 2012, they didn't have any vegetation. They had low values for NDVI. You can look at, yes.
Okay, go ahead.
No, just say what you wanted to say.
Yeah, I was looking at it. It's okay, click back and let me see the 20. This is 12, 15. Disable. Let's look at. Okay, let's disable.
Let's look at
let's look at 12 first.
2012 and 2025.
Okay.
Yeah, there's a problem. This is 2012. This is 2025.
You see?
You can see like all this batch.
There is no improvement. It's worse.
It's worse. It's getting worse, eh?
It's complete worse. No improvement anywhere.
Yeah.
It's not going to be. If there was, I would say that's then maybe it's another data from another country. This one, no way.
You can attest, eh? Now,
sure.
this type of change in early warning system is an indicator of an oncoming famine. Right? It's also an indicator for climate change, for onset of drought. Okay, so if your early warning system are showing onset of drought, then know that there is going to be an onset of what? Of famine. And henceforth, you need to start planning. either at the regional level or at the district level on how you're going to tackle this, because it means that people are going to struggle with their livelihoods. They are going to struggle with feeding themselves. They're going to resolve to severe coping mechanisms. So this is the time it will inform your project and also the funding model. So if there are any field activities that you are doing, you can couple this data with household data to really give it context. So at this point, you'll also want to understand, is weather, is precipitation and temperature also behaving the same way? Okay. And then we have what we call PCA, Principal Component Analysis. I don't know whether you are familiar with PCA.
Mm-hmm.
Principal Component Analysis. No?
No. I'll write it down. I'll check it out.
Okay.
Principal.
Is a great way of analyzing these types of data. We will cover it, don't worry. Okay. So, yeah. So how do I know? How will I tell? Okay. If I wanted to know what the percentage, now you can see the geographic area is very huge.
Mm-hmm.
And for this, for some reason, the spatial data set here is continuous. So just saying maybe this amount of kilometers or maybe this amount of area is not enough. You want to measure the change as a percentage.
Mm-hmm.
So is the change in percentages improving? Is it becoming big? Is it becoming smaller? Is it a large increase? Is it a small decrease? Or maybe no change at all? So this now introduces us to anomaly maps. Anomaly maps is what we use to report on change detection for vegetation and climate data. I'm going to give you a material that will help you understand your way around agroclimatological data, that is precipitation and vegetation, and how to report and present this on your reports and dashboards. Okay, so you need to look for funding, or maybe this is an urban area, so we'll just maybe accept that population is on the increase. Yes. And this is also an indicator of rural-urban migration. It's also showing increase in the built-up area. Okay, this might now be all built-up space now. Or agricultural
Do
land.
we just as we have for the NDVI?
Yes.
Would you also have for like housing?
Yes.
How would you? If we had the two,
Yes.
we can interpose and we'll see what is causing the loss of vegetation. Is definitely not farming.
Yes, you're very right. You're very right. That now brings us to land cover and land use, or what we call land use and land cover change analysis or change detection. Okay, land use and land cover change detection. And this utilizes still satellite imageries. Okay, yeah, so we'll get to that. So let's see how to create our anomaly maps. How do we quickly analyze this and just be able to say there is a change? How do we show it empirically? Because at this level, a normal person will not understand this. So we need to tone down this to infographics. That brings us to anomaly maps or change detection maps. For change detection maps, I'm going to do a change detection between 2012 and 2025. Okay, and then I'm going to do one that is annually, that will look at 2012 to 2015, 2015 to 2047, then 2047 to 2025, 47. And then I'm going to work with a long-term mean. All right, we're going to work with a long-term mean and look at how is the variation from normal observation. Okay, LTM. Like let's say maybe if the average temperature is maybe 35 let's say maybe let me put it at 95 ml. That might be the average. So if you are getting something like maybe 47, that means that is this observation is lower than normal observation. If it's let's say 200, it is higher than normal observation. So that's how we report. Let's see how to go about it. Now, how do we do calculation, raster-based calculations? How do we do raster-based calculations? We use, under the raster menu, we have what we call the raster calculator. Okay, the raster calculator is the one that is going to run. You have been used to the normal calculator, all right, for quantitative data. Now let us look at the raster calculator for spatial data. Now, just launch it like this. And before you launch it, make sure the files that you want to work with are loaded. Okay. So if I wanted to do change detection from 2012 to 2025, I'll pick the two data sets. All right. So I'll say, find the change from 2025. So you double click on it. Now I want you to notice that we have 4 areas. We have the raster band area, we have the result layer, we have the operators and the raster calculator expression area. Okay, so we double click here to load it here. And then I'll do what? If I'm going to do change, it's the difference. I'm basically finding the difference. So I'll say, find the difference from 2012. So I've used minus here, the minus symbol. Or okay. So I'm going to find the difference between the raster file from 2025 and 2012. So this is a difference of how many years?
2025 to 2012.
Or like 12 years.
This is giving us 13.
Yeah, 13 years. Okay. So once you do this, this is right. This is okay. The next thing that I'm going to do is to create an output file. Right? So this will result to an anomaly raster file. So the values that you'll see on this raster file are not NDVI's values, but the change in NDVI value. Okay, so I'll say output format is going to be this output layer. Just a minute. Output layer, I'm going to specify the output layer. And then I'll opt to have it under I'll have it here. So I'll say, I'll just call it this is Greater Accra. Greater Accra. And then I'll say anomaly. Anomaly. So say 2025, 2012. And then we'll say save. Okay, make sure the coordinate system remains the same. And we run, okay. And it has done something. Let's look at it. There. All right. So now we have a negative change and a positive change. We have a negative change up to 190. The areas that are in black are the areas that experience the greatest change, the greatest decrease in vegetation cover, because you can see here under our raster band, we have up to 190. Okay, don't worry, I'm going to let us show you how to reclassify this. Okay, now to reclassify this, I'll say properties, go to properties, make sure it's collected and selected. And then symbology, under symbology, currently single band. I'm going to switch it to pseudo. Okay, yes. And then the red will show the areas that have undergone the greatest change, while the green are the areas that where the vegetation improved. Okay, and then we will apply. Now, I'm going to apply this the way it is. Now under mode, we have continuous, we have equal interval. For now, I'll just leave it at continuous. I can also decide to pick the number of classes if I want, right? I might say maybe these are too many classes and maybe I want to have fewer classes. This is where you do it here. But for now, let us just run it the way it is, using the normal, the default settings, and say apply. And okay, there you are. So these areas where you are seeing the reddish, these are the areas where we have had very huge decrease in vegetation cover, right? And the areas where maybe you are seeing these blues, these are the areas where there have been improvement in vegetation cover. Any question to this bit?
Fascinating. No question.
No question. Yes. So in our next session, we are going to see how to work with research tools, point sampling. Point sampling, yes. So yeah, we'll leave it for now. We'll leave it here. You break for your lunch, and then we meet at 2 Ghana time. Okay. All right. This is an NDVI anomaly map from 2012 to 2025. So it's a period of a difference of 13 years. So we are assessing change in vegetation cover using the NDVI index. So the next thing is to get empirical evidence, right? So how do we do that? If we are talking numbers, all right? So the next thing is to determine the area that have experienced change. All right. So far, you can see this is what we have. So what if you wanted to understand if you are doing forest monitoring? This is very good for forest monitoring. Which areas are where the forest is receding and all that, which areas are undergoing the desertification and all that. we transform this raster into a vector. Okay, so how do we translate this raster into a vector? This is now under reclassification. So we're going to reclassify these pixels to qualitative data. So we're going to see now at this point we have to talk about scales and your legend. Okay, so if we are experiencing 0, then it means there is no change. If you're experiencing a positive values, it means, what does it mean if there are positive values?
It's a change.
Yes. Yes, there's a change. Now, a change can be positive and a change can be negative. So if a change is positive, it means what?
When the change is positive, then eventually we are having changes, and that negative means, or the opposite. Negative means more changes, and positive means there hasn't been change. Oh.
Okay, let's look at this scale here. There has been a negative change in NDVI from 2012 to 2025.
Negative means it's bad, really bad change.
Let's see whether it's true. I'm going to pick a point here. I can still use the identify tool, or you can use sample points, right? But before we come to that, will come under point sampling. Point sampling. Anyway, let's see how to vectorize this data set first. Then we'll come to point sampling. Now, a normal person will not understand this. If we're informing maybe the project, maybe the ministry, they want to work with numbers. All right. So how do we extract numbers from here? So this is at change detection level. So we are going to use percentages. You can use percentages, or you can use a scale of maybe five groups, 4 groups. I'm going to have no change, minimum change, high change. Is it really like that?
No, yeah.
Okay.
No change.
Let me
Yeah, that's
back
fine.
a little bit to statistics. Let me take you back to statistics.
No change.
So if we need a sample point, let me just pick
marginal 1, 2, 3, and then 4, and then high change.
Yes, we can say point A, point B, point C. So point A in 2012 can have an NDVI value of, let's say, maybe 58 or 59. And then in 2020, in 2025, it now has maybe a value of 14. All right. So our anomaly map for that pixel will read what? It will be 59 minus
14. minus, right.
So that gives us what? That should give us 30. Oh, is it 30?
2025 is 2025 is 14, so we get a 45. Yeah.
45, yeah? 45.
No, 45. 45.
So it's a positive of 45. So this means NDVI reduced. So how do we call these positive values? We can say we can have small decrease, large decrease.
Okay.
So this is the decrease.
Okay. Okay.
Is it really true?
Yeah. Because in 2012 it was 59.
Mm-hmm.
Now the value dropped to 14.
I think it's the other way around.
Yeah.
Let me
If it was
uh,
2012, okay, that
it should be
means
14.
let's
It
take
should be 14 minus 59, making it negative 49, negative 45.
if it has dropped, okay.
So
Okay.
change
Instead of
change is current minus
minus previous
previous
or past.
or past, yes. All right, so it becomes 2025, which is 14 minus 59, giving us a value of negative 45. This is a decrease. So for decrease, so we're going to either have two groups, decrease, no change, and increase.
Is that was before? Decrease, no change, normal, and an increase.
Yes, so under decrease, you can break this into two. Small decrease, large increase, large decrease, small decrease. The same thing for increase. So we are going to maybe say, if it's no change, then we are having values of 0. And then I'm going to have small decrease. Sorry. Large decrease, small increase, and large increase. So we can have these 5 groups. So for the decrease, we can maybe say up to, we're having 28, then we're having 90 here. So for small, I can say this one should run up to something like what? Let me give it 20. And then this should be above 20. More than 20. And then same thing to here.
No, small decrease, small decrease, you made it 20, and large decrease also 20.
Yes.
So we have virtually
Making
0
sense.
to
Yes.
0 to 20. And
yes.
why don't we make it higher than
0 to 20.
or meaning right?
And this should be above.
Oh, okay.
Now,
Good.
this is 20 to negative 20 to negative what? 0 to negative 20.
Okay.
And then this should be above, I don't know if it's above negative 20, but you get my point. Now, we have different pixel here with different values, right? So we want to convert these regions into polygons so that we get an area coverage. We look at the distribution or the extent of this change. Now, I'm going to use this. Now, at first, you have to decide your classes. These are your classes. Okay, so how do we get this? Now, we go back to our raster calculator. We now have Greater Accra anomaly 20 to 2012. So we are going to reclassify this so that we have discrete regions. Okay, anything that is between -+1 to 20 should be small decrease. +21 to above, that should be large decrease. This is how we program this. You run, you come to raster data, raster calculator here. Okay, we get our anomaly map. It's here. Okay. And then I'll say, if it's equal to 0, now this value refers to the pixel. What you see here at 1, at 1 pixel, this means at 1 pixel. All right. So if we find a pixel that equals to 0, then what?
We are going to say no change.
Yes, but it cannot store what? Rasters can't store text values.
So text file, okay.
So these groups, we are going to give them codes. Okay.
Rasters cannot.
Yes. So for 0, we'll just maybe leave it at 0. For small decrease, we can assign it 1. All right. For large decrease, we assign it what? Can assign it 2. For small increase,
okay,
we assign 3. And then this, we assign 4. So our pixels are going to be reclassified to this value, either 0 and 2.
It's 2. Right? No, that should be 3.
Should be 3.
You put
Yes,
2.
you are right. Yeah.
Okay.
Is it clear to that bit? Okay. So then 0.
I get it now.
You are familiar with this, huh? So we have the if function here. So I'll say if. Then 0.
Then.
Just give me a minute. Sorry. Okay, I've just coded it here. Now, I've used this syntax here. Let me copy it, then we understand it. All right, so this is our pixel. This refers to the pixel. All right. So if the pixel reads 0, then there's this asterisk. We multiply by 0. So the value of this pixel is going to be converted to 0. And if any pixel is more than 1, then the value, if it's more than 1, oh, yes. Let me just expand it a little bit. I don't know whether you can see this. Is it clear? There's this plus here. Okay. So I'll tell you what it does. So this is the first class. Okay. And then the second class will start after the plus. And this one is looking at the values that are between 1 and 20. Okay. If the pixel is more or equals to 1 and less or equals to 20, then we assign class 1. Okay. And then a plus. So instead of using if, we use a plus. Then we find anything that is above 21, we assign 2. Greater anomaly, sorry, and we also do for -1 and this. So you have it in this manner. Just maybe have a look and just to understand. So we are not using if for now, but you can still use if. Right? So instead of if, I've just used plus. This is one if you are conversant with PAL and all that. But just understand this is how you structure it. It's not, it doesn't change. Now this is what we have here. Okay, so it's going to generate our classes and then we're going to classify them.
Okay.
Now, it's going to resolve into a raster data set. Okay, so we have to give it. So I'll call this Greater Accra anomaly reclassified. I'll just say reclassified. Like that. And then we will save, maintain everything the way it is, and then say okay. And there you have it. So you either have a 0 where you have dark. So where you're seeing darks, it's where there was no change.
Okay.
And then where you have 4, now from 1, 2, 3, all the way to 4 for the different classes. All right. Now, this is good. This is very good. So you can still put this, you can still visualize this raster using pseudo color. Let me invert this. So where there was no change, you'll see it as blue. Right, where there was big change, you'll see it as red. Let me apply and see. Okay, so there's been a very huge change, very huge, large decrease. Is it large decrease? Yes. Yes, there's been a large decrease. So let's work it through. Now, I'm interested to look at the coverage. So this might be for this, what has been the percentage change in coverage. So I call it we vectorize we vectorize this reclassified raster. And the way we vectorize, we come to raster, and then there's, yes, under conversion, we have rasterize vector. So wait, it's under polygonize, raster to vector. Okay, so I'll say polygonize, and then we get this window here. Now this is the game changer. I'll pick our classified raster as the input layer. Then we have the band number. Just going to use band 1. Then number of fields to create, we are going to store it under the digital number. You can call it digital number. You can call it class. Or you can call it change. Okay, so I'm just going to call it change. Where will I put this vector? I'm going to save it to a file under NDVI datasets. I'll say Ghana, and then okay, so the file name, I'm going to call it great but this time it's not going to be a TIFF because it's a vector file. We will change this save as type into shapefile. Okay, and then I'll store it under here. And then we'll say save. And then I'll say run. Any question to this bit?
No, I think we are fine to go.
Okay. Great. Now, there's our vector. Okay. If you open this, you should be able to see a series. Okay. You can opt to merge or dissolve. So I can come under vector and say dissolve. It's not here. Okay, that's processing. Oh yes, dissolve here. Okay, so we pick our classified, the dissolve field. I'll just select the change. Then okay. So the dissolved one, I'll save it also to file. I'll just call it so this is our final product. So I'll say save. And then I'll say run. Great. Now it's here. I can switch off some of this. So I have it like this: 3, 4, 0, 1, and 2, 3. Now the next thing is to calculate the area for each class. All right. So currently, maybe if I quickly just visualize this, maybe just to so that you can see the change. Under symbology, I can change this to categorized. And then here, I'll pick change. I can use random colors. Okay, let me pick this, and then I'll say, okay. And then we will classify. I'll remove this. We need to invert this color around. Like that. Apply. Okay. There. Now, when they talk of traceability systems, let me maybe talk about the application areas of this. EU. So this is your reclassified raster. So you can rename this to the large increase, small, like this one here. I'll say no change. Here I'll say what?
I said minimal was no change. Then we had which one is that? That's large. Okay. We said large increase. Large increase. That's a large increase, and then the 3 will be small increase.
Sure.
3 is small
Just
increase.
a minute. The one, this should be a decrease, huh?
Yes, it's a small decrease.
Wait.
One is a small decrease, and
no,
3
no,
is a small.
One, just a minute. Here, this is positive 1. How had we done it? This one here should be a small increase.
So,
and this is a large. And then
what you can do, you did the 4 for it to be a large increase, right? Then 3 becomes a small increase. So what you were doing was right. You just go ahead.
Oh, yes, you are right. So in that manner, in that order. So now let me mention something just a little bit here. Now, if this is the scale you are using to process your data sets, your raster data sets, then you maintain the change. So do not come and use other, like maybe now this time you say maybe to 50. Don't do that. Maintain this throughout your analysis and for all your temporal data sets. Yeah. Let it be even across the board. Yes, that will help you compare in terms of comparative analysis. Yes. Yeah, so you're going to maintain this. You might want to write this somewhere. In your report, in your analysis report, you'll document which classes you have used and the ranges of those classes. So for our case here, this is going to be a small decrease. And then This is a large increase.
Yes, yes, yes. And then a small.
Yes. Like that. Apply. Okay. There you have it, like that. Now, we want to compare over time. Okay. And we also want to compare over space. So what do we do? So we're going to find the total area coverage. So change detection can be done. You can use area coverage, spatial coverage to look at it. And then you can look at this change over time. So if you are trying maybe to see in 2020, 2021, how much has been the change, this is what you are going to do. So for now, this is the change between 2025 and 2012. Okay, and this is how it's going to go. So from this raster, from this vector here, I'm going to maybe open the attribute table. You have it here like this. Okay. We are going to run spatial statistics. Okay, but before we do that, we are going to create to calculate area for each of these polygons. Like, let me maybe use the select tool so that you see what I'm saying. So these are the areas that had the large increase. So what is the area coverage and what is the proportion of this large increase? All right. So for that, we calculate the area. Right. Area is spatial analysis. So to calculate area, you need this data set to be in UTM. Okay. You need it to be in UTM. So what do? We convert this to UTM by simply selecting it and say export, save feature as. We will follow the same thing. I'll show it in the same area. NDVI datasets, Ghana NDVI. I'll maybe pick one of these. I'll just mention that it's UTM so that I'm able to know. So I'll save it. And then here under the coordinate system. So this is a geographic coordinate system. So we are going to give it a projected coordinate system. And I'm going to use this common one. This is global, is equivalent of WGS 84 in UTM. So we use sudo Mekata 3857, but feel free to use the local one for Ghana, if you have for Ghana. For purposes of analysis, I'm just using this. If I wanted to compare it in different countries, then sudo Mekata is a good choice because it can be used globally.
Okay.
Yeah.
Okay.
So at this point, just maintain everything the way it is, and then you say, okay. So we have our file here. Now, you see this styling. This styling, we can copy it to our file here, greater. So I can come here for this file, this styling, I right click, and then I'll say styles, and then I'll say copy style, and then I'll just say symbology. Okay. And then I come on the destination, select this, right click, select styles, and then say paste style. What am I pasting? Symbology. Paste the symbology there. There you have it. Okay, that's how you can move styling from one data set to the other. Now, something needs to happen on this file here. So I'm going to open attribute table. We need to find area for each of these classes. So what will I do? I'm going to run here. There's this part here that says field calculator, right? So open it. Under the field calculator, you're going to access some other algorithms. The one that we are looking for should be, let me maybe expand this a little bit. We find area. So you can see we have $ area. So for this this value, I want to calculate area. And where is this area going to be stored? So I'm going to create a new field, and the field name is going to be called area. And please note that UTM is in meters. So this area calculation is going to be in meters. So it's in square meters. Right? If you want it in kilometers, then you will need to do something down here. Right? So I can say maybe in kilometers, square kilometers. So, and then output file, maybe integer, no, let me pick real. Precision of 3, that's okay. And then I'll say, double click here on area. Okay. Just like that, open, $ area, just like that. And you can see there are values that are here. Okay, so to convert square meters to kilometers, what do? You divide by 1,000,000. Right? And then we run. And there you can have. So where are we experiencing the biggest change?
And a 4.
Okay, I'm going to do something. I'm going to create a new field.
2, 3, 1.
It should be 4, 3, and 1, right? Yes, and these are classes. So I'm going to do something. I'll create a new field and call it class. This can just be text. Okay. So we said here was no change. All right. Here was large increase.
Okay.
No, this should be large decrease, large decrease.
Beta. Okay.
Small increase. Then we save it. Now, these values, you can map it on Excel, right? So I can You can copy this. Control C and have it somewhere new. Oh, my classes. I'm not seeing my classes. Is it leaving it out? It's leaving it out, eh?
Yes, yeah.
I can use copy selected rows. Eh? Let me use copy selected rows. And then interesting. It's leaving it out. Now, if it's not copying, you can use this feature here, export, save feature as, and then we'll change this from S3 shapefile to CSV. Okay, our file name, I'll put it under change vector. I'll say Greater Accra NDVI section. Save. And do okay. All right, so let's see. There it is there. So this means we can open it in Excel. It's here.
Yeah.
Yes.
Are we? Hold on, please.
Okay.
Possible. You answer. Oh, okay. Then Danny.
Yes.
Hold on. Okay.
Go ahead, sir.
No, that's okay. Continue.
Okay.
Continue. Now the thing is becoming another thing. Huh?
You can use this. You can use this. It's you to decide, and maybe pick this.
Oh, that grabs all this.
So this is Greater Accra. Okay. Yes, and then we can do something here. I'll display the data labels. Now, you can still do percentages, right? We can work the percentage here. So, okay, you can calculate this, but I'm maybe just going to redo this, insert. This time I'll put a different, like this. Okay.
Now it's like a movie.
It's a movie. Hey. There. This should be what? Value, really. Category name, eh? Yes, like that. There. So 62% of the land cover has experienced a large decrease in vegetation cover by 62% from 2012 to 2025. This is now we are reporting, eh? Yes. While this is small decrease, followed by a small decrease of 26% area that experience a small decrease. And then 3% of the vegetation cover did not experience any change over the last 13 years, over the last decade. Okay, yes, so that's how you go about it. Now, this is for Greater Accra. Okay, so if you wanted to find out for maybe the different regions, then you repeat the same thing, but for the different regions. Any questions up to this bit?
This part is fine, but now how we got to this is where, you know, the movie comes into play. But don't worry, let's see.
Oh, this one.
I'm following the concepts.
Oh, yes. You remember we did, let me just circle back to that. It's a very good question. Thank you for asking. How will we know change detection? How will we know that there has been a change? Okay. We tone down, we use percentages to report. People understand percentages and values like large decrease. They will not understand NDVI. So
Mhm.
the analyst uses metrics like NDVI to try and monitor that change. But while reporting, you do not use NDVI to report because most people even don't know what that indicator is.
Right. Mhm.
So
Mhm.
we have given the NDVI anomaly
Mhm.
classes.
Mhm.
You can
Mhm.
either say it was a large increase, a small increase, in that manner. So we gave it classes. And then because it's spatial in nature, we wanted to calculate the percentage coverage of the entire area.
Mhm.
So if it's a
Mhm.
large decrease, what proportion of the entire area experienced that?
Mhm.
All right. So for this, we have used area. We
Mhm.
used area. You remember we
Mhm.
calculated area? Let me open the
Mhm.
attribute table. Yes. We
Mhm.
came and ran an area algorithm here under
Mhm.
field calculator, this one here. All right, using the area function, which was able to give us this.
Mhm. Mhm.
Okay, now this is what we have converted into percentages.
Okay.
Yes,
Okay.
this is what you are seeing here. So we
Mhm.
copied this, we exported this. I did
Mhm.
just the normal export into CSV. Export,
Got it.
got it, Great, great.
Mhm.
So I took it back to Excel to really tone down the results of my analysis. So I have it here. So you can couple this with your map. For example, let me just do a quick one. You can take a screenshot of this. All right. You can take a
Mhm.
screenshot of this. Let me see
Mhm.
how it's going to come. Just a minute. Deselect this. Save. For this, I'm just leaving out the legend as for a small while, but you can always bring it back. So if I was doing my report here on Excel, then insert. Let me have a new like this, and then I'll copy them. They fit really. Let's see. Okay, I might want maybe to switch it a little bit. This. And then we can give it a title. Eh? I'm going to give a text box. And there you are. That's your map. Any question?
I will not say a question.
Do you see these labels? Now, one more thing.
It's
Huh? Yes,
yes,
sorry?
it's interesting. It's very intriguing. But
Mm,
then you see how to get here. What
mm,
you've done is excellent. I mean, I get the whole concept, but
okay.
again, there's a need to really work it out before you get to this point. It's like I said, each time you do it, a lot of things come to mind as
Mm-hmm.
to what this tool can be used for.
You are right, yes. So
They mhm,
that's how your change detection map will look like. Decide how you
mhm.
want to place the visuals. Feel free to combine your map with infographics like charts and graphs.
Okay.
Yes. So this marks the end of today's session.
Mhm.
From tomorrow, we're going to see how to create maps inside QGIS.
Hmm.
If,
Wow.
if you are doing an early warning system, how will we set up one in QGIS? If it's in Power BI, how do we set up one also? And then early warning system has a lot to do with indicators.
Mhm.
Yes.
Mhm.
And you remember we talked about data-driven triggers or data-driven alerts? Yes. So this is it. So I can say there is a lot of concern here for Greater Accra. You can see there has been
Hmm.
a large decrease.
Mm. Say it again.
All right. Yeah. Mm.
Hmm.
All right.
Mm.
If there are no questions, allow us to end
Hmm.
today's session.
Okay.
Yes.
Wow. Okay. Thanks, Dan.
You too.
Now how to implement these. I'll do it.
Yes.
I'll
Now,
get it. Don't
for
worry.
your takeaway, I would like you maybe to
Mhm.
try this with the precipitation data set. Precipitation is rainfall.
Mm.
Yes, the one that
Mm-hmm.
you
Mm-hmm.
downloaded.
Don't
Yes,
worry with that. Okay.
yes. You
Hmm.
can find
Mm-hmm.
one for 2012. If you don't get for 2012, just get any two years, at least 5 years minimum. But if you can
Mm-hmm.
get 10 years, it's going to be good. And then just do the same thing and let us see where the rainfall has receded or where it has improved or where there has been no change.
Hmm.
Yes.
Hmm.
If now,
Hmm.
this can also be used to do most at risk mapping, or what we call most at risk population maps.
Mm-hmm.
Most at risk population. Yes. So these areas that are in red, any population living within this area is a most at risk population of famine. They are at risk of famine and drought. So if you
Hmm.
have population data, yes, I'll show you what to do with population data tomorrow. You can
Okay.
estimate, right? Also using this data set, this annual data set, we can forecast how it's going to look like based on the trends that we are having. How will it look in maybe in 2030? Right? In 2030, there will be
Okay.
no vegetation in Accra.
Hmm. Hmm.
Anyway, it's
This
just
is serious, huh?
yeah. But the change is there. All right.
Oh gosh.
Thank you,
All
sir,
right.
and see you tomorrow. I'll take questions. You can send me via WhatsApp if you have any questions.
Well, let me put my hands on before I know whether I have questions.
Okay.
Yeah, we'll see.
Okay, sir.
Thanks. Thanks.
All right.
Thanks. Thanks a lot.
Okay. The videos continue using the same link. Okay. Let's look up. Um,
Mhm.
This is our final product after doing the change detection analysis using NDVI raster files from EVIRS and EMODIS satellite missions. So this is our final product. It's an anomaly map. That means it's showing you change. Its data storing is around change detection. So yeah, I want you to explore and see the techniques used in mapping. We can start with the color in terms of how it's communicating. So you can see there's consistency in color from the map to your infographics, that is a pie chart and the bar chart. The column chart, yes, column chart. Yes, well, like for example, where you have the red, that's where you have a large decrease from normal observation. So we have a large change or a large decrease in change of our vegetation cover, meaning the vegetation has decreased or receded. Okay, so when you're working with climate data and vegetation data, your final products, okay, your final GIS map output, they display, we call them anomaly maps. However, as you are building your analysis toward that final product, you will be required to create other types of maps in between here. Okay, but your final output, the one that you communicate or share out, it should be an anomaly map, unless otherwise. Okay, so this is very good in change detection and monitoring of forests. Monitoring, if you want to monitor the onset of famine and desertification, this also will do very well.
Okay.
So EMODIS and EVIRS satellite missions are dedicated. Right? They don't collect any other thing. They just focus on NDVI values. Okay, so from this map, we can see there has been a 62% in reduction. Right? So most places are what we are. So what does this mean for us? 62% of the land cover has experienced a large decrease in vegetation. All right. So that is NDVI. It has experienced a large decrease in NDVI, meaning vegetation quality and amount has gone down in terms of coverage. So 62% of Greater Accra is experiencing desertification or onset of desertification. Okay, 62% of the land cover of Greater Accra region is experiencing onset of desertification. That's what it means for us. Okay, however, we've had changes around this area here. It should be an, I saw some swamp. I'm not sure, let me confirm. Yes, this area here. Okay. There's been some small increase. So I think this swamp is a protected area. That's why you can see, yeah, that explains why the vegetation has been improving. area here.
You know, I was looking at this morning. Yesterday, I couldn't really do a lot, but in honesty,
Mm.
this whole map makes sense.
Mm-hmm.
Um, so if you look at it, if you drag it up a bit, just drag it up, I'll show you something. No, drag it up rather. Yeah, let's go up. Now, this area here, where your mouse is, move your mouse down to the to your left. Come to your right, sorry, your
Okay.
right,
Okay. Mm-hmm.
where you have a small decrease. That part
Mm-hmm.
you see is Accra itself. That's Accra.
Mm-hmm.
Okay. Now, it's small because virtually you saw structures being built and then the rest.
Yes.
But
Mm-hmm.
the other areas where you see large increase, a large decrease,
Mm-hmm.
are the areas that are developing. For example, to the extreme
Uh,
left,
mm-hmm.
that area is called Kaswa.
Okay.
Now, that was where the refugees camp started from.
Mm-hmm. Mm-hmm.
So it was not planned. They just dropped the people in there. So you see, it's completely red and it's been out of order for a long time and it's
Wow.
continuing. Okay, so there isn't a real plan for that area.
Wow.
Okay,
And
yes.
this is
So the
interesting.
area, yeah, the areas where you see the small decrease were settlements that were made. For example, Accra. So
Mm-hmm.
Accra, you have shops and everything. It started its civilization early. So you can only make use of spaces available.
Uh-huh. Yes, yes, you are right.
You understand? You can only utilize, yes, people are building whatever, but they are mainly making use of spaces available already. Maybe there was a structure there already, they've broken
Mm-hmm.
it down and they put up a new structure.
Mm-hmm.
But in the other areas, they're cutting the vegetation. People are like, this is the space. Maybe it was a farm before. He goes
Mm-hmm.
in there and says, this is mine. I want to put an estate there.
Mm-hmm. Ah,
Yeah.
interesting. Very insightful.
Okay, so that's
Mm-hmm.
why you see that outside of Accra, as you go in, you
Mm.
see the vegetation dropping intensely.
Uh-huh.
Okay,
Uh-huh.
right.
Okay. Yeah.
And this is where the government should try and put in places and say that, look, here there should be a tree, or this should be that, or that should be that. But there is nothing like that. Once the person comes in and he knows that this is his property, he
Mm-hmm.
does anything he wants, whether to cut down the trees or to do what. Nobody has any control because he feels it's for him.
Wow.
Okay, so if that trend should continue, we would virtually have the Greater Accra becoming red. Why? Because people are also trying to move into the city center. Virtually, this is where the airport is. This is where they feel
Mm-hmm.
is the city. This is
Mm-hmm.
where there is life.
Mm. Yes, yes, you are right.
Okay,
Mm.
so when people move from, let's say, the north, blah, 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 their final destination is the city, Accra.
Mm-hmm. Mm.
Okay.
Yes.
And probably he does work and does that. He's able to buy a plot in there. Okay, there's a tree on the plot, cut it down. And then he builds.
Wow. Wow.
This is what is happening. Now, as you move towards the right-hand side, as you had mentioned,
Mm-hmm.
now you are getting to the right-hand side. Let's go to the right-hand side. This is along the coast. And
Mm.
along the coast, you cannot do that much. Okay,
Yes.
people will try to develop, but you can't do that much because these were areas that have been developed. Most are for the government, and
Mm-hmm.
um, people own the land, so you can't change that much.
Mm-hmm.
Now, as you head towards the place where you said that there's a mangrove, now you would notice that this is where the river Volta that starts from the north
Mm-hmm.
empties itself into the Gulf of Guinea. Scroll,
Mm-hmm.
scroll, scroll to your left. Move it further to your left, and I'll show you. Yes, good. So here, the river you're seeing there is the Volta.
Mm-hmm.
And so it's moving straight into the sea. You would see that with time, here became a tourist attraction close to the riverbank.
Ah,
Here, it
okay.
became a sort of tourist attraction, which was previously ignored. And then people started to cut and develop estates along the line. So that's why you see it there deteriorating, going red.
Mm-hmm. Mm-hmm. You are right.
Okay.
You are right.
Yes. So
Yes.
that is what is happening here. So previously it was green because I did my national service here in this area.
Wow.
I was teaching. I
Wow.
taught there for 1 year. And at that time,
Wow.
it was
Mm-hmm.
green. People didn't have value for the land there. But with time, as it
Mm-hmm.
was going and people could see that, oh, there are water bodies, we could do that. People started buying properties there. They
Mm-hmm.
started developing that place because of the river water.
Wow.
But
Wow.
instead of focus on agriculture, which has not been that strong along the entire river Volta,
Mm-hmm.
you don't see that. There hasn't been anything in terms of agriculture per se, but it's rather more of developing, cutting down trees and what have you. Yeah. So it makes sense.
Wow. I see. I see. This is very insightful. Thank you
Yeah.
so much for the background info.
Uh-huh.
It has
Yeah.
really,
It makes sense.
yes, it makes sense.
It makes sense. The other thing that I would say is to as we've seen the vegetation growth, with this narrative, it would be good to superimpose with satellite images the development, whether what we are saying,
Mm-hmm.
this is coming from my mind, whether it makes sense. What has caused the reduction in vegetation? We need to see whether it's been truly development, the buildings keep popping up and what have you, or what is it? Okay. And for me, I sense very well that it would be development. It's more of development people cut it because if they were still using them for farms, we would see more greens.
Yes, yes, you are right. You are completely right.
Yeah.
So that's your satellite image.
Mm, mm,
This is the time you also want to do land cover change
mm-hmm.
or land use, land cover change. So
Right.
yes, and seeing has it also been receding over time or increasing?
Oh, okay. The area that I know
Mm-hmm.
which has been decreasing, you go to the left. Let's go back to the left.
Mm-hmm.
Go further. No, let's go to the right. Sorry, the right. Right. Go. Keep going.
Mm-hmm.
Keep going. And then zoom into that area between, yeah, zoom into the where the river exactly. Yeah. Again. No, to the far end. Let's go down, down, down. Yeah. Where the development is. Exactly. Here, I know, or it could also be that there the settlements here have been experiencing the sea washing into the land.
This is what you're also saying. You can see there's a lot of development here.
Yeah.
Okay, where you're having small
Mm-hmm.
change and it's large decrease.
Mm-hmm.
You can see
Mm-hmm.
these are all buildings.
Mm-hmm.
Mm.
Mm-hmm.
So
So
this is where we're
yeah.
having a small decrease.
Mm-hmm.
And you can see initially we had vegetation here.
Mm-hmm. Mm-hmm.
Yeah.
Mm-hmm.
And let me maybe, Yeah, this is what you've been saying. It's true. So all this area has experienced a small decrease in NDVI. Yeah.
So, for example, this building that I'm seeing here, highlighted with the red, I'm sure the building was either broken down and rebuilt.
Yes.
Where you see the red, you know, yeah, these are new buildings that have popped up. Okay, and like I said, they are more of tourist. These are islands.
Okay.
Okay, and yeah, they are developing it more for tourism. This is an island. This is another island. Okay.
I see.
Okay. So in reality, it would have been I don't know, but once there's vegetation, the sun there is not perfect. It's both from the river and from the sea, so it has a little bit of salt. But once there is vegetation, it means that it could be good for farming.
Yes, you are right.
But no one is looking at that. Yeah. So this is interesting. Yeah, very interesting.
That's art observation for you now.
Yeah.
Yeah.
I'm looking for it to be able to really do this on my own, and but I'll go through the video. I want to be able to do these things very well.
We can try one with you while you screen share.
With this one, no, I think we will pick up on what do you call it? Our time. I thought you have a schedule for today, so yeah, let's go through the schedule, and then rather when I start the like assignments, I'll be knocking on your door intermittently when you have some time in
Yeah,
your
sure.
hand.
Sure.
Yeah.
We have a post-training support, a 6-month post-training support.
Okay.
So yeah, that's remote sensed data and its role in GIS and spatial data analysis, and its application in change in climate and vegetation change or monitoring, right? Forest monitoring, it also goes in there. Mangrove forest, it also goes in there. We have a different one for mapping the bases of the sea. We call them bathymetry, but our applications will not go there.
Right.
This is for people who are into water. Oceanography. Yeah. They study the bases of the sea, and others. Anyway, now geodatabases. Let's talk a little bit about geodatabases because our data is now growing huge. We are now producing output. We are now having data products. How do we